All right, today I'm going to show you guys how to do two-step mole problems. And the question I guess a lot of you might have is, well, how do you know when it's a two-step problem? And it's really pretty simple. If you're going from, say, moles to grams or grams to moles, moles to volume, volume to moles, or moles to particles or particles to moles, if the problem's got moles in it, typically that would make it a one-step problem. Moles is kind of our base unit for solving problems. If it doesn't mention moles, then it's more than likely a two-step problem, because if you are going from, say, molar mass to particles, you've got to go through moles to do that. And if you're going from, say, volume to a mass in grams, you've got to go through moles to get to the mass in grams. And it's just a two-step problem. You convert from volume to moles and then to grams. And again, if you'll follow what the mole map tells you to do, again, multiply with the arrows, divide against them, and it's simple. We set them up using conversion factors. So this problem here says we got 13.2 grams of iron, and they want to know how many atoms are present. So like I said, it's a two-step problem. If it doesn't mention moles, you got to convert to moles first. So the first thing you need to do is you've got 13.2 grams of iron, go to moles first. Remember, we always have to cancel out our preceding unit. So we got grams of iron here, and then in a conversion factor, we would say 1 mole is how many grams. You look that up again on the periodic table. You can see that iron's mass 55.8, and then you plug that in. And then, so now we've got rid of grams, and now we have moles, and then we're wanting atoms. So put atoms of iron at the top, moles here. Cancel that unit. 1 mole, again, the number atoms again would be particles. And so we're going from moles to particles. That could be atoms, molecules, or formula units. We multiply by 6.02 times 10 to the 23rd because, again, that's how many particles are in a mole. Multiply, cross, and divide. 13.2 grams times 6.02 times 10 to the 23rd divided by the molar mass of iron. You get 1.42 times 10 to the 23rd atoms of iron. Think about it logically, that's a smaller number than what's in a mole because we don't have a mole. We have a fraction of a mole. A mole weighs 55.8. We only have 13.2 grams. The next question, we got grams of sulfur. They want to know what volume that would occupy. Again, since it doesn't mention moles, it's a two-step problem. We're going to convert to moles first. So write down what we have, 7.55 grams of sulfur dioxide, which is SO2. Cancel out grams, go to moles. 1 mole is 64 grams. Again, you find that since it's sulfur dioxide, you look up sulfur's mass, 32, times 2 oxygens because it's SO2, and that's how you get the molar mass of 64 grams from the periodic table. And then they want to know what volume that would be. So you're going to liters, and 1 mole is 22.4 liters. So again, 7.55 times 22.4 divided by 64. Would the mole map, again, tell us the correct thing to do? We started with mass. So to get to moles, we're going against the arrow. We divide by molar mass, which we did. That was 64. And then we went from moles to volume. This would tell us we're going with the arrow there to multiply by 22.4. That's what we did. Mole map, again, is always correct. You're setting these problems up. So 7.55 times 22.4 divided by 64, 2.64 liters of SO2 is your answer there. The next question, which would contain more particles, 46 grams of sodium hydroxide or 46 grams of carbon dioxide. And really, all we need to do is convert them to moles, because the more moles you have, the more particles you have. Because remember, by definition, a mole is 6.02 times 10 to the 23rd of anything. And so if we got more moles, we got more particles. So take each one of them, 46 grams of sodium hydroxide, convert that to moles. Again, the molar mass of NaOH, you get that from the periodic table again. You add up sodium's mass, oxygen, and hydrogen, add them all up, they weigh 40. So 46 divided by 40, that'll give us 1.2 moles of NaOH. Same thing for carbon dioxide, 46 grams of CO2. Again, we're going to moles of CO2. CO2 weighs 44 because carbon weighs 12 and 2 oxygens weighs 32. So 46 divided by 44 is 1 mole. So the one that has the most particles, again, would be the one that has the most moles, and so that would be sodium hydroxide. Now, the problems at the bottom here, These, I'll be honest, over the years, I've had more emails from former students that are in college that are working problems like this than any other problem I think I've ever seen. And so I guess they could be a little bit difficult, but notice what I'm saying here is this: be aware of the representative particle of any substance. And here's what I mean by that. If you're starting off with 16 grams of C6H6O6 and they want carbon atoms, if what you're starting with is not an atom, in other words, what is that? Is that an atom, a molecule, or a formula unit? That's a molecule. We can do this problem then from grams to molecules in 2 steps. We could, because that actually is what does it right there. That gets us from grams. We divide by the molar mass. We multiply by the number of molecules of glucose, but we didn't answer the question because they want to know how many individual carbon atoms are there. So if what you start with, this is a molecule, does not match up with what they're asking for, you have to do another step. They want to know how many individual carbons are in that molecule. And you can see, you can count them up, there's 6 of them. So you have to do one additional conversion factor. And you have to say one molecule of C6H12O6, which is glucose, has 6 carbon atoms in it. So since there are 6 carbon atoms in each molecule, you convert to molecules and then multiply your final answer by 6. And like I say, I've had so many people struggle with that over the years because they don't make sure that, again, like I said, if you start with 16 grams of glucose and you go, okay, that's a molecule, and they say, how many molecules is that? You're done right there. But if they want to know how many individual atoms are in there, you got to multiply it by the number of atoms that are actually there. If they said how many hydrogen atoms were there, we'd have to multiply the final answer by 12 because each glucose has 12 hydrogens in it. Same thing for the one at the bottom. We're starting off with 45.8 grams of calcium nitride, and calcium nitride is an ionic compound, and the smallest part of an ionic compound, this is actually called a formula unit. That's what that is. And they want to know nitrogen ions. That's not a nitrogen ion. So what we can do is we're going to go from grams to moles to formula units of this, and then we're going to multiply it by the number of nitrogens that are actually in there. So calcium nitride, when you cross the charges and put it together, is Ca3N2. And so what we end up having to do, since each formula unit has 2 nitrogens in it, we got to multiply our final answer by 2. So again, how are you going to know you needed to do that extra step? If that's calcium nitride, that's a formula unit. If the question was how many formula units would that be, they match up. Like what that is what they're asking for. You're done right there. You saw, again, go from mass to moles to formula units, because remember again, formula units are particles. It is the smallest part of an ionic compound. And you'd be done, but they want to know how many individual nitrogens are there, and since each formula unit has 2 nitrogens, all you're doing is multiplying your final answer by 2. So pay close attention to problems like that. Like I say, they seem to be tough for a lot of people, and that is it for doing 2-step problems. You'll work some more in a minute. Good luck.